In previous videos, we performed subnetting manually. We've used a magic number method as a shortcut, and I wanted to give you the shortcut that I use when I take a certification exam. I call this my 7-second subnetting process. This shortcut is designed for exams. You're able to subnet very quickly, and you don't have to perform a lot of mathematics to confuse things while you're trying to perform these calculations. In fact, there's almost no math involved other than adding one and subtracting one. The first thing you would have to do is to create the tables, and then once the tables are created, all of the subnetting refers back to values within those tables. You'll probably want to look at the magic number method and the 7-second subnetting method to see which one fits best for you. And what you'll find is as we go through this 7-second subnetting video, it seems that a lot of the process is duplicated from the magic number method. That's because there is really no other way to perform subnetting other than the processes that you see in both of these shortcuts. But there are ways to customize it for the way that you like to be able to subnet, so feel free to grab from either or both of these methods and find a way to subnet that works best for you. One of the challenges when using the 7-second subnetting process is that it expects you to have a chart ready to go. If you're sitting in a testing center, they commonly give you a whiteboard and a dry erase marker, which makes it a little bit easier to create the chart. But if you're taking your test online, you still have a digital whiteboard that you can type on, so you may want to try typing these charts out manually just to see how well you can create and use them if everything is online. The 7-second subnetting process takes into account that all of these different subnets follow the same format. For example, a subnet mask of 255.255.255.0 gives us a single subnet. But if we borrow a bit, we can have two subnets because our subnet mask would be 255.255.255.128, and those two subnets would have host ranges between 0 and 127 and 128 to 255. If we're continuing borrowing bits from the subnet, we can separate it even further into 4 separate subnets, or in the case of 255.255.255.224, we have 8 separate subnets that we've created, all from that original subnet mask. And obviously, the range for that particular subnet is between 0 and 31, which is compared to the original range of 0 to 255. Knowing that these relationships are in place, we can create some charts that can help us with the subnetting process. I like to use a chart that summarizes all of the CIDR block notations for the first octet, the second octet, the third, and the fourth. And if you looked at our previous video on the magic number method, then this chart looks pretty familiar. We then want to be able to calculate how many networks would be on a network that had that subnet mask and how many addresses per subnet that would be associated with. We might also want to add the conversion to decimal from that CIDR block notation for each of these individual masks, depending on which octet it happens to be in. For example, if the octet is a /25, we know in the fourth octet that our subnet mask value will be 128. You can see with this chart created, you can perform very fast calculations between CIDR block notation and decimal notation, and you also have predefined numbers of networks and addresses per network that you can also use during the subnetting process. I'm also exceptionally bad at multiplying and dividing when I'm in an exam situation. So in order to avoid any problems with the math, I tend to write out all of the network address subnet boundaries, especially between 32 and 4. I can usually remember the 128s and the 64s and usually 32, but when you get to 16, 8, and 4 devices per subnet, it becomes difficult to exactly know where the boundaries are for those particular host ranges. This is the identical subnet boundary chart that we created for the magic number method, but for the 7-second subnetting method, it's almost required, especially if you don't want to perform any math. The 7-second subnetting process begins with converting the IP address and subnet mask to a decimal value, which is especially important if they give you a CIDR block notation. And of course, we've already created a chart that does that very, very quickly. That chart also tells us the range of IP addresses for each individual subnet as well. Once we've done the conversion, we can determine the network and subnet addresses. That second chart shows us the different boundaries, and then we can calculate our broadcast address and our first and last usable IP address. You'll find as we step through this, that this process goes very quickly. And by using the 7-second subnetting, you actually can perform a subnet and calculate all of these values in 7 seconds or less. Let's calculate the subnet address, broadcast address, first usable host, and last usable host for this address, 165.245.12.88/24. We know that the /24 is relatively easy to do in our head, but it makes for a good example to start the 7-second subnetting tutorial. Let's first convert the address and the subnet mask to decimal. Obviously, the IP address is already in decimal, but we need to convert that /24. So we'll go to our chart that shows the /24 is our third octet, and that is a decimal value of 255. So we'll bring down the 165.245.12.88 by adding 255s to the left of the value that we've created with the /24. We'll add the /24 value of 255, and anything after that will be a 0. And you probably already knew that the subnet mask of a /24 is 255.255.255.0, but you can see how the chart that we have really narrows down where the masks are for the /24 in the third octet and how that decimal value is converted. Now let's calculate the network or subnet address. If our mask is 255, we're going to bring down the IP address. So 255 and 255 and 255 are our first 3 octets. So we're going to bring down all 3 of those addresses, meaning that the first 3 octets of your network address are 165.245.12. If the subnet mask is a 0, we would bring down the 0. So you can see here our subnet mask in the 4th octet was 0, meaning that our network address is a value of 165.245.12.0. Now let's calculate the broadcast address. If our subnet mask is 255, we're going to bring down the address. If the subnet mask is a 0, we're going to bring down and use a 255. This means that our broadcast address in this example is 165.245.12.255. Now the process for determining our first usable IP address and last usable IP address is simply adding 1 to the network address and subtracting 1 from the broadcast address. This means we'll calculate our first IP by referencing that network address, 165.245.12.1, because we added 1 to our network address. The last usable IP address is based on the broadcast address, so we'll use 165.245.12, and then we subtract 1 to make that 254. Now we have all of the values we need for this particular subnet of 165.245.12.88/24. Let's use exactly the same IP address, but this time let's change our subnet mask. Let's perform exactly the same process with 165.245.12.88/26. The first thing we want to do is convert the IP address and mask to decimal. We'll look at that /26. We'll find that in our chart. It's in our 4th octet, and we can see that it correlates to a 192. So in our 4th octet, we bring down the 192, and all of the other octets for the subnet mask are 255, meaning that a /26 converts to 255.255.255.192. You'll also see on that line with the /26 and the conversion to the 192 that the number of networks is 4 and the number of addresses is 64. So 64 is our address range for this subnet. So we're going to look at that single line of 64 to determine where this particular network happens to be. We're going to do that by looking at our IP address of 165.245.12.88, We know the 88 is associated with that 192. We find the 88 is in this range between 64 and what is 127, or 1 minus the number of the next particular range. So that means that the value that we're looking for, or the subnet that we're interested in, is this subnet right here of 64 devices. Let's now calculate the network address. If our subnet mask is a 255, we're going to bring down the address. If our mask is a 0, we're going to bring down a 0. And in this case, none of those octets happen to be 0. And we have in that fourth octet a number that is not 255 or 0. It's 192. So we need to look at our chart and see that the 192 has 64 addresses per subnet. We need to look at that 88 and see where it is in that block of 64. And it happens to be in that second block that also starts with the value of 64. So we bring down that 64 value, making our network address 165.245.12.64. This multi-step process of determining what the subnet mask is, how many hosts happen to be in that particular range, and where that range sits in this chart is the key to the 7-second subnetting process. If you can perform that process very quickly, everything else happens almost automatically. Let's calculate the broadcast address. We perform almost exactly the same process as our network address. If the mask is 255, we bring down the address. If the mask is 0, we use a 255, and in this case, the mask was not 0, it's 192. So we go back to our chart. We know that 192, we have a 64 addresses in that subnet. We find where the 88 happens to be, and then we look all the way down our chart to determine what the next starting value is in the next set of addresses. And in this case, it's 128, so we subtract 1 from that to give us the broadcast address, which is 165.245.12.127. At this point, we have everything we need to determine our first usable IP address and our last usable IP address. We add 1 to the network address to give us the first usable IP, which is 165.245.12.65, and we subtract 1 from the broadcast address, giving us our last IP address of 165.245.12.126. Let's do another example using exactly the same IP address, but we're going to change the subnet mask to a /20. The first thing we need to do is convert our IP address and our subnet mask to decimal. The IP address is already in decimal, so we'll simply bring that down. But then we have our /20. So we want to come down to our /20 in our chart. We can see that it's in the third octet, and we know that the decimal version of that is 240. So that means that our mask will be 255.255.240, because it is in the third octet, .0. Now we can perform the calculation for the network address. We're going to, of course, highlight that line that has the /20. We know that that /20 has 16 addresses in a single subnet. So we're going to also highlight the line that shows all of the 16 host values. Let's now calculate that network address. If the mask is 255, we're going to bring down the IP address. So our first 2 octets are 255. If the mask is 0, we're going to bring down the 0. And then for any other number, we refer to the chart. We know that this subnet has 16 IP addresses in a subnet. We know that we started with the value of 12, which means it's in this very first range between 0 and 15. Since it's in that first value of 0, we would now bring that 0 down to identify the network address, meaning the network address for this IP is 165.245.0.0. Now let's calculate the broadcast address. If the subnet mask is 255, then we bring down the address. If the mask is 0, we would bring down a 255. And then we refer to our chart. We know that we are with 16 addresses in this subnet, and we would use the last address in this range, which is a 15, meaning that our broadcast address is 165.245.15.255. And now the easy part, where we calculate the first IP and the last IP based on the network address and broadcast address, meaning that our first IP is 165.245.0.1, and our last IP address is 165.245.15.254. You can see that making simple changes to the subnet mask changes the network address, broadcast address, and the usable IP addresses for each of these subnets. But you're able to use both of these charts to determine any combination of these regardless of what subnet mask might be provided. Let's change up our IP addresses and perform the same process again. In this case, we'll use 18.172.200.77/11. We'll convert that IP address and subnet mask to decimal, and we may want to look at our chart and see that a /11 is in the second subnet, and we can see that it converts to a 224, meaning that our subnet mask is 255.224.0.0. Since we know that we're using that /11 or 224 in decimal, we can highlight that line showing that there are 32 addresses per subnet, and we can highlight the 32 address range in our lower chart. Now let's determine what the network address is. If the subnet mask is 255, we'll bring down our network number, and if the mask is 0, we'll bring down the 0. In the second octet, where it's neither 255 nor 0, we have the value 224. We know that this is the 32 addresses per subnet. We have highlighted our 32 address range. So let's take that value of 172 and see where it fits in that entire range. And you can see that it's the range between 160 and 191. So since we're starting with 160, this is our network address, we'll add the 160, meaning that our network address is 18.160.0.0. Now we'll calculate the broadcast address. If the mask is 255, we'll bring down the address. If the mask is 0, we will bring down the value of 255. And again, we'll refer to our chart where we have that second subnet of 32. We also have in this range, starting with 160, we know that it goes all the way up to 191 because the next range starts with a 192. So our broadcast address is 18.191.255.255. And now we add one for the network address. We can do that by adding 18.160.0.1. And we subtract one for the last IP from the broadcast address, making the last IP 18.191.255.254. Let's do another one just for fun. We'll do the same IP address of 18.172.200.77/17. We will take our IP address and then we'll convert our subnet mask to decimal. We'll look at that /17. We can see that the /17 is in the third octet and it converts to a 128. So our subnet mask is 255.255.128.0. We'll highlight that on the screen so you can see that that 128 range has 128 addresses per IP subnet, and we'll highlight that 128 range here on the top of our chart. Let's now calculate the network address. If the mask is 255, we're going to bring down the IP address, and if the mask is 0, we're going to bring down a 0. If it's any other value, then we're going to have a look at the IP address, which is 200, and we're going to see where that fits in our particular range. We can see that it's on a subnet where the first IP address is 128. So we're going to bring down the 128, making our network address 18.172.128.0. Let's now calculate the broadcast address. If the mask is 255, we're going to bring down our address. If the mask is 0, we're going to bring down the value of 255. And then we'll have a look at our third octet where we have the value 200. We know in that particular range, it goes all the way to the end, which means that it is going to be 255. Our broadcast address then is 18.172.255.255. And now you can add one to your network address to get the first IP. So the first IP is 18.172.128.1. And we subtract one from the broadcast address to get the last IP. So that will be 18.172.255.254. I recognize that the 7-second subnetting method requires that you have these charts available in order to perform these calculations. But for me, when I'm in the middle of an exam, this provides me with a lot of speed, especially if I get a lot of subnetting questions. With Network Plus, this might be a little bit overkill because you might get 1, 2, or maybe 3 subnetting questions. But if you take other certification exams during your career that have much more subnetting, You may find that this method helps you quite a bit. So you might want to practice creating these charts prior to starting your exam. Try writing down the charts or try typing them out online so that you can be prepared for whatever method you'll be using during your exam. You'll find that it will take probably a minute or two to be able to write down everything you're going to need to perform a 7-second subnetting process. If you go into a testing center, they usually give you a piece of laminated paper or a whiteboard that you'll use for your exam. One of the challenges, though, is they often give you a pen with a very fat tip, making it difficult to write out these very detailed charts. I will often bring my own dry erase marker. I'll check in with the front desk. I make sure that they look over the pen and I ask permission to use that dry erase marker on the exam, and they've always allowed me to do that on previous exams. This makes the process of writing the chart, and perhaps more importantly, reading the chart, much easier during the exam process. Ultimately, you want to find the process that works for you. If you think 7-second subnetting is too tedious, try to have a look at the magic number method or find some happy medium between both of these that is the perfect process for you to use to be able to perform these subnetting calculations.